Hi everyone, welcome back to our channel. Today we are going to solve these coupled coils which are connected in parallel, and now we need to find out the voltage drop across the resistor RL, where RL is given as 5 ohm. Okay, let's try to write down the 2 kVL for the for the two loops, and let's try to evaluate. I am assuming that the current I1 is flowing in this direction, and I am labeling this current as I1, and the current which flows in this loop or this mesh I am labeling as I2. Now let's try to write down the KVL equation. So try to apply Kirchhoff's voltage law at loop 1 or mesh 1. Okay, so we are applying some voltage. Let's try to write down source voltage is 10 at an angle 0 is equal to this. I'm going to write this, all is the load I'm writing here. Okay, so this is the self inductance and this is the self inductance, but these two have a mutual inductance of plus j omega m. Okay, so here inductor we are going to write down as, generally you can write down the inductor in Henry, or you can write down in AC format as plus j xl ohms. Okay, so plus j xl ohms we can write down it as plus j into xl can be written as omega l ohms. So this is what directly given here. It is plus j into 1 into l value given is 2 ohm, which is nothing but j2 ohm. So J2 is nothing but directly the XL value, which is nothing but 2 ohm. Okay, that's what given in here in the problem. Okay, now input voltage is 10 at an angle 0, and here you are going to see here what I am going to have. So the current I1 only flows here, so I am going to write down plus J2 multiplied with I1. Okay, is nothing but I into R. Okay, and here the current I1 is flowing here and current I2 is flowing in opposite direction, and the common resistance is minus J3 of I1 minus I2. Okay, now this inductor is completed and this capacitor is completed, but this inductor is linked with this inductor. Okay, so here you can see here the current I2 is flowing like this, and the current I2 which is flowing in this branch like this. So here for the current I1, the dot is there at entering. For this coil, the dot is there at leaving, therefore you are going to get minus. So current is entering the dot, current is leaving the dot, then you are going to get minus. So what is that value? Minus of, so what is the impedance upward, which is J 0.707 into, so this is the mutual inductance due to which current? Another current, which is nothing but mutual I2. Okay, so this is what the first equation you are going to get. Let's try to simplify I1 terms and I2 terms. So this I can write down 10 is equal to J2 I1, this is minus J3 I1, so this is minus into minus is how much? Plus, which is nothing but J3 I2. Okay, and this is nothing but minus J 0.707 I2. Okay, so here you can take I1 as a common, so 10 is equal to, I am taking J I1 as common. So in these two terms I am taking I1 as a common term, which is nothing but 2 minus 3, and in this term I am going to take I2 as an common, which is nothing but I2 is equal to, J I2 is equal to 3 minus 0.707. Okay, therefore you are going to get this value as 10 is equal to minus 1, which is nothing but minus J I1, this is nothing but plus J I2 into, this is we are going to get it as 2.3. so let's try to assume it as equation number 1. So now next step is applying KVL in the second loop. Apply Kirchhoff's voltage law in loop 2, in the second loop. Okay, try to apply here. Okay, so there's no entering voltage, 0 is equal to, let's try to write down from this element. So this has an, let's try to write down, all these are drops. So what is the current in this branch, which is nothing but I2 into 5 ohm, this is nothing but voltage, and here we are going to get the impedance is minus J3, the impedance is nothing but ohms, I2 minus I1. Why? Because we are writing for the second loop. When you are writing for the first loop, I1 minus I2, here it is minus I2 minus I1. Okay, and coming to here, so the current which flows in this branch is plus J1 into I2. Okay, so this is nothing but ohms into I2, but this has a mutually inductance of plus J, so therefore you can see here current is entering the dot and here current is leaving the dot. Same we are going to get the resistance of plus J 0.707, which is nothing but ohms, multiplied with the value of this is with respect to primary coil, therefore you are going to get I1. So one is at entering, one is at leaving, automatically you will get the negative polarity. So now let us try to solve. So this is equal to 5 I2, and when you multiply it, this is nothing but minus J3 I2, minus into minus is plus J3 I1. Okay, so minus into minus is plus J3 I1. So this value you are going to get J I2. This you are going to get minus J 0.707 I1. Okay, so from here we are going to take I1 as an common term. Okay, so 0 is equal to J I1 we are taking, which is 3 minus 0.707 and taking I2 as an common term. Okay, so when you take this I2 as an common term, therefore you are going to get I2 of 5 minus J3 plus J. Okay, so this is what you are going to get. So just to simplify it, you are going to get I1 into J. So 3 minus 0.707, which you are going to get as 2.3 plus I2 into you are going to get 5 minus J2. Okay, plus J3 plus J you are going to get minus J2. So this will be our equation number 2. Use your calculator using complex mode, then you are going to get I1 and I2. So therefore when you solve it, therefore you are going to get the value of I2 is equal to 2.6 at an angle of in the polar form as minus 34.6 amperes. Okay, so the voltage drop, okay, the voltage drop, which is nothing but I into R, which is nothing but IL into RL. So the IL value is 2.6 at an angle of minus 34.6 multiplied with the resistance value of 5. Okay, so when you multiply this, you are going to get as 13 at an angle of minus 34.6. so this is the voltage generated across this load. Okay, so the voltage generated here, it is approximately 13 volts. Okay, so this what's happening by connecting a capacitor. You see here already 10 volts we only applied, but this is creating drop. But when you are connecting this capacitor in parallel, it is increasing the voltage and giving a voltage of 13 volts. This is how to solve the problems in coupled coils. Okay, so very simple. So this is how to solve the problem. Slowly solve the problem of your own. If you feel my explanation is good, please like the video and share the video with your friends. And if you have any doubts, let me know in the comment section. And if you are watching my channel for the first time, subscribe to my channel with the name Thulasi Ram. So for these more updates, watch my channel. So hope you are able to understand, and this is a free channel for the development of students and faculty. Kindly support these sort of channels for the development of students and faculty. Viewers, obediently from